This is the second attempt to video this removal of the FM section. The first one went with the wind, just lost it. Anyway, I've just placed it back gently and I'm going to explain what was necessary to remove this thing. First of all, the unit is fixed to the bottom chassis with 4 screws. There's these 2 here and there's 2 more on the inside. You just remove the screws from the underside and the whole thing just comes loose after you desolder this ground connection. There's one there and there's one there. So those get desoldered and this comes loose. So the next step is to remove the dial cord, which is held in place there. And then you have this thing basically wobbling around. Then we have to disconnect the wires that go to it. Now there are surprisingly few, fortunately. This wire is soldered on here. This is actually the heater connection. It's got a ferrite bead in there. So that's desoldered. The other one is the antenna connection. These 2 are desoldered. They're fairly straightforward. And there is then the other side has these connections which come out from the underside. So I have desoldered them on the underside and these 2 wires come through, leaving that mess that needs to be cleaned up later. But what we have now is a completely isolated FM section, which is a lot easier to work on than if it was stuck in the main chassis. Now to remove this one section from the main one, there's a section that's loose here. You take off 2 screws over there. You have to desolder this point here, which is basically shorting, making connection between one part of the chassis and the other. Same over there and same over there. Now once you've done that, this actually just comes out like that. And there's nothing here except a bit of a mess, and it's the top of the chassis. So we'll put that aside for now. And this is what we're left with. This mess is the FM tuning section. In the middle of all that grime, we have to find our problem. And I've had a look at it, and I think I need to dismantle this a bit more, because my problem is that there's the tuning capacitor. I suspect there's a short in a big part of the tuning capacitor. This tuning capacitor has 2 sections as well, as we'll see in the schematic soon enough. But I suspect there's a short, and to check for a short, I could find the points on the circuit here where they will give me access to the ends of the 2 tuning gangs, but they have coils across them. These are tank circuits, so you have a coil and a tuning capacitor in parallel. And obviously by virtue of the coil's characteristics, it's basically a short. They're very small coils, very few windings on FM, and you practically measure 0 resistance anyway. So I can't really measure continuity between the stator and the rotor of the coil of the tuning capacitor with the coils in parallel. So I have to actually disconnect the coils to check that the tuning condenser is not shorting. And to do that, I have to remove this other part of this casing. And it seems that to do that, I have to make this slide through there. Now this is a little loop of wire and it's coming through an insulator. I think I can unwind it, slide it through there. Same with this one. There's a ferrite bead at the end of this. This is the B+, so there's a ferrite bead at the end of that. And then, let's see what else. This will just go in. I have to unscrew these guys. I have to desolder that. And then I think, yes, I have the same situation here. I have part of the internal chassis soldered to the outer one. So I have to desolder those guys. So I'll get on with it and show you what the result is when I've done it. There's another soldered point to a ground tag over here. Most of this video is actually for my reference as well, so I remember to put things back later. It does help. Well, it doesn't look like these guys actually go through. I thought they'd be loose, but they actually seem to be stuck in there, so I need to desolder the other side. And to do that, I think the best thing would be just to desolder that there, where those two, that's a B plus coming to a 2K resistor and a 10K resistor. So if I loosen that there, that'll disconnect it from that end. And this one here comes into the bottom there, which means I can desolder that and just remove it. Right, and then of course there's this ground wire, which is actually connecting to the ground of this yellow cord inside. And after quite a bit of wiggling and desoldering, this thing has come out. They're actually connected to the back chassis quite firmly by these two ground connections, ground soldered connections. One is on the tuning capacitor and the one is on the top. So you have to use a very hot soldering iron to actually desolder that one and get it out, and very, very carefully prise it out, otherwise you're going to break something. So now we have access to the whole thing. We can see the tuning capacitors, gangs, both of them. I actually see one of them is skew. Oh, that could be nothing. Anyway, first step, I'm going to clean this whole thing up and then methodically go through the schematic and test components. I've never actually opened one of these up like this, but this is a small one, as I've mentioned before. This is actually a very small unit, very simple circuit, and it shouldn't be too difficult to see where everything goes. But as you see, there's only 3 blades on that capacitor. There's 4 on that one. A few capacitors here. This bugger is going to get tested because it's looks exactly like the one that played a trick on me on the other part of the radio. So this is it. Tuning capacitors, coils, more capacitors, a few resistors. Should be a piece of cake, I hope. If you recall, the last time I showed you this, I had it in my hand and it was out of the casing and it was out of the chassis, and I said that it looked like a piece of cake. Well, those were, as is to be expected, famous last words. This thing has been out of the case twice, out of the chassis twice. And what I've found so far is that there are no problems with the components. They're all fine. The actual tuning capacitor is fine. It's not shorting at all. I had to desolder a hell of a lot of all the coils, or at least one side of each coil, so that I could get the tuning capacitor measured properly. I tested the tuning capacitor across its whole range, and there are no shorts. The components measure fine. There are no tricky capacitors like the one we had in the AM oscillator. And I believe what I have here, I've changed the tube, and I believe what I have here is another case of a non-functioning local oscillator, but this time in the FM band. Which, if you know a bit about these front ends of FM tuners, is one heck of a problem. At least for me it is, because I don't really have any equipment that goes into those frequencies. And I don't particularly care to invest in new equipment, simply to sort out a little problem, italics for little, on one tuner. This is the first FM tuner that I've had that's completely dead. I've had improvements with components changes. I've had improvements with changing the tube, but this is the one that's completely dead. And I have gone through this, I can't tell you how many times, and I just can't seem to get the problem sorted. Now, I'll show you what I can do. I can actually do the IF alignment on this, and I have aligned it and aligned it and aligned it, thinking it was a problem with the alignment. And it seems that it's more likely to be a problem with the settings of the various coils in here. These two over here, that one in the back and that one, those are the IF adjustments. So that's basically adjusted for tuning the IF. That's fine. Although I do find it a bit strange that for best IF reception or best IF transmission, which is a 10.7 megahertz, these little ferrite cores are practically out of the casing. Now, because I have no reference to what they looked like before this was a problem, I cannot tell you whether that's normal or not. But because I'm not getting any reception, I can't actually test for improvements. Now, what I've done is I've put a 10.7 megahertz signal on here, and I've managed to get the tone to actually come through. So besides the actual alignment that I've done, I've actually got the tone coming through. What I've done here is I've connected the 10.7 megahertz to a shield across or over the ECC85. There's a 10.7 megahertz signal coming in here, and I've modulated with a tone, FM modulated a tone on here. So what I should be getting, what I want to test, is if that signal is going through the tube, through the system, into the filters and through those filters. Now, I've aligned those filters. Now, if this signal has gone through the filters and it gets to the other end and it happens to have an FM modulated signal on it, I should hear the tone coming out of the speaker. Okay? Now this is what happens. It's there. Listen to it. I'm putting the volume up. Okay? So that tells me that the ratio detector, everything else, all those stages are working after this stage. And this, these two here that adjust the IF alignment part of the can are also working because I'm getting that signal coming through. Right, so we've got the front end, as it were. The front end is this part. We've got the rest of it working. Now, I need to figure out whether this thing is failing on the RF amp or on the oscillator section. So what I do next is I'm going to send a signal, a radio signal from one of those little transmitters, and I've used this before, one of those little car transmitters. I'm going to send a signal through into the radio. It's just going to pick it up by the antenna, and I'm going to see whether I can detect that signal anywhere here. So let's do that next. So here I'm sending a 92 megahertz signal. I'm basically transmitting a carrier at 92 megahertz with this thing. It's just lying on the ground here. There's no signal going in, so this is just the carrier. It's lying across that wire, which is the antenna, 92 megahertz. And I then am going to switch it on. Well, 92.1. Just clicked something on there. I've then put that little sniffer coil that I use across that coil over there. Now that coil over there is the coil that actually feeds the first RF stage of that ECC85. So that's the RF amplifier circuit. Okay? Now I want to know if this thing's actually resonating. So let's look at the scope and I'll show you what we're getting. This is a signal with the tuning dial up at the top. Now, as I come down and I get closer to 92 megahertz, look what happens. If I stop, that little thing's just gone off. There it is again. So if I stop at the peak, there's the peak. Let's see what we have on the dial. The dial is near as damn it 92 megahertz. So that section seems to be working, and it actually seems to be quite aligned in terms of RF. Let me try and increase that frequency and we'll see what happens. Let's look at the scope while I do that. So I'm going to this little thing and I'm going to, obviously I'm touching it, but I'm going to put it up to, say, I'm actually increasing it slowly, and I'm going up to 95 megahertz. 95 megahertz, right. Now I'm going to tune it to 95, or to a peak. There's my peak. Okay, I'm going over, coming back, there's my peak. Now let's see what frequency we've actually got. Damn close to 95. So that tells me that something is working on here. What that tells me is that this first stage, this is the antenna coil. That's the actual oscillator coil, rather the actual coil that's tuning with the tuning cap for the front end, for the tuner section, for the antenna section. It's peaking at the right frequencies. It's actually receiving that signal that I'm sending from the little transmitter, and it's peaking it. So I know that that part of the circuit is actually working, and that signal gets pretty strong. I mean, it's, I think the measurement there was 56 millivolts. You know, it's not bad. It's actually a pretty strong, solid, and constant signal. And when I increase that frequency of the little transmitter, so I'm basically, you can call it an RF signal generator. When I change the frequency of the signal generator, it actually reflects it on here, and I can tune it in with the tuning cap. So that tank circuit seems to be working. What is missing seems to be the oscillator section. Now let's look at the schematic, and I'll try and explain some of that. So I've got the signal coming in through the antenna there. That's the coil that I call the antenna coil. I can actually peak that. I haven't shown it, but I can peak that. The signal's going into the cathode. This thing is common grid, so that grid is grounded. That's just your heater supply with all the filtering and cleaning up and all that. So this thing is being amplified, and it's coming through there to that coil over here. Now that's the tank circuit that actually tunes the RF. That's the one that I'm measuring. That's the one I've got the little sniffer coil on top of. Now when I tune the tuning capacitor there, I get the effect the tank circuit actually oscillates the right frequency. So that signal goes into there. The question is it getting to that tube? That's the question. And now the next stage is, where's this signal? This is the local oscillator. Now the local oscillator signal should always be about 10.7 megahertz above that frequency. So if I've got 97 or 95, say, megahertz peaking there, I should have 107.7, beg your pardon, peaking over there. That does a mixing. It's a self-oscillating mixer, which then sends it to that IF coil, IF transformer over there. That's the part, I believe, is not working. Now, what really bugs me is that there are so few components here. And I've checked them and double-checked them, and I still haven't got that working. And obviously, by now, the tuning of that coil has been messed with. I mean, I've messed with it. I presume somebody else had messed with it because it was all right out or right in. I'm not sure anymore. That thing is working. So I've been scratching my head, and I've decided I've got to do something drastic. I'm probably going to have to dismount this whole thing and rebuild it again and see what happens. But I'm still giving it some thought. But that's basically where I am right now. And that takes us back to that image that you see at the beginning of this video, where you see a second radio sitting up on the front here. What I'd done there is I'd taken the front end of that FM, I'd taken this section basically of that radio, and I connected it. You see, that's the connection there. I connected that from that point there to this radio, replaced this one with the other one, and that works perfectly. So that tells me that once the signal gets out of the front end and goes into that first stage there, it's working. So it's not there onwards, it's there backwards. It's definitely in this FM front end. And so I'm going to have to do a little bit more thinking about that. I'm going to have to do a little bit more dismantling perhaps. And hopefully I'll be able to come back soon with a little bit of joy, because this is really doing my head in. It is such a small, apparently simple circuit. I mean, that's all it is. It's one tuning capacitor, a fixed capacitor, a coil, a little cap, and that should be oscillating and mixing with the signal that's coming from here and have a difference of 10.7. Now, because this thing's been messed with, it might actually be oscillating and I just can't see the oscillation signal. I've tried with the scope. I don't seem to see any signal that's constant or consistent, because I might be way off. I might be way off the 10.7 megahertz difference that I need. I might be resonating this thing at 50 megahertz, for example. That's a 97, so 47 difference. There's no way any of them will go through there, because what I'm getting out there is I'm getting 97 or 95, say, from this one. And then I'm getting, say, let's say this is 50. I'm getting the 50. And I should be getting the difference, which this is 95, that's 50, this should be a 45 as well. But I'm not getting anywhere near the 10.7 that I need to actually get an actual signal going through here. So either this thing is not resonating, oscillating at all, or it's oscillating way above or way below the frequency that I need to oscillate it at to get that 10.7 megahertz difference and create my IF that I need to hear something. So that's it for now, and hopefully next time I come back I'll have some good news. Bye for now.